Good afternoon, Atish, Jishnu, and Sai Vignesh. Am I audible?
Yes, sir.
So just give me 5 more minutes time. Some more students are ready to join. Okay, and then we'll get started. In the meanwhile, you can have your MTG books also ready. You can have page number 313 ready of your math book. Students, am I audible?
Yes, sir.
Okay, so we'll get started. So I hope you're able to see my screen also.
Yes, sir.
Okay. So this is the chapter we are supposed to get started, right? Is there anything pending? As far as I remember, areas related to circles is what we are supposed to start with. Am I right? Yes or no?
Yes, sir.
Anybody with an answer? Am I missing something?
Yes, sir. Yes, sir.
This is the chapter, right? Okay.
Yes, sir.
Okay. So take your notes, write it down. This is chapter 12 and it is named as areas related to circles. So I'm sure you would have learned it in your school also. But today we are going to concentrate on the foundation part and then we are going to do some problems from the MTG book. Clear? So with that being said, we'll get started. Right. So I want everybody to open MTG page 313. So in MTG, open page number 313. Okay. Right. So since the name of the chapter is areas related to circles, right? So when you talk about the area of a circle, what comes to your mind? See, first of all, when you think of a circle, right? When you think of a circle, what comes to your mind? So circle is basically a shape which has a fixed radius. Am I right? So how do you define circle in the first place? So how do we define it? Right? Can someone tell me? How do we define circle as?
Points equidistant from a certain point.
Yes. So
Infinite number of.
very good. Yeah, that's right, Vishnu. So you have a fixed point, right? From a fixed point, let's say you're taking multiple points, right? Which are equidistant from that fixed point, right? Which are equidistant from that fixed point. Then when you join all those points which are equidistant from the fixed point, you get a shape. And that shape is called as a circle. So what does this shape? There are two parameters that are associated with the shape. One is it has a length associated with it. Am I right? So are you guys able to see me also?
Yes, sir.
Yes, sir.
There is a length associated with it. And what is the name given to that length for a circle as? It's called as circumference. Am I right? Right? So
Yes,
basically, circumference is the perimeter of a circle. Right? Similarly, when I take a closure, it is going to occupy some area. So what do you mean by area? Area is the region that is occupied by the two-dimensional shape. So when you take a circle, right? Circle is two-dimensional. If you extend the circle to three-dimensional, it will appear as a sphere. So as of now, our concept is related only to circles. I hope this point has got registered. So when you discuss about a circle, there are two important things that you need to have. One is called circumference, which is the length of the circle. And the second is area. Area is the region that is occupied by that circle. Okay. So having said this, you already know what is the circumference of a circle with radius R. Can you tell me what is? So what is the circumference of a circle with radius R? It is 2 multiplied with a constant called pi multiplied with R. So it is 2 pi. Right. Similarly, when I talk about the area of a circle, what is it going to be?
Data by 360 into pi r square.
You are talking
Pi r
about the
square.
Is sector. Area
you're
of sector.
talking, so I'm talking about the area of the whole circle. Area of the whole circle is pi r.
Okay.
Okay. So this is the length of the whole circle. This is the area occupied by the whole circle. Now, with this basic knowledge, what we are going to do is we are going to try to understand what are discussed in this particular chapter. Okay. But before that, I'm just going in the order of the book. So when you write circumference, we wrote it as 2 pi r. But when you define a circular shape, one parameter that you can define is radius. And the other parameter that you can try to define is the diameter. So generally for the diameter, the symbol given is small d. So what is the relation between diameter and the radius? So diameter is going to be 2 times radius. Right. When this is the scenario, this 2 into r, can I write it as diameter? So I can write the circumference of the circle as pi into d also. Right. I know there's a basic point, but I wanted to explain this. Right. Similarly, when I talk about area, area is going to be pi r square. This from here, can I say r is equal to d by 2? So if I take r is equal to d by 2 and substitute it here, what am I going to get? I'll get pi into d square divided by 4. So pi d square divided by 4 is also another area that you can use. So in this chapter, we are not going to like this application is going to be more in the chapter name surface areas and volumes. At that time, what they'll give you is they'll give you certain diameters of they'll give you the diameters of certain shapes. At that point, you can use this formula. Okay. So I hope this point is clear. Right. Now the question is, so if you see page 313, under the competition window, right, under the competition window, they have given something. What is it? So if two circles touch internally, so let's say I have a big circle and I have a small circle which touch each other internally, then the distance between their centers will be equal to what? So if I take this to be center 1 of the bigger circle 1, if I take this to be the second circle and I say this is C2. Now read the question carefully. What they are saying is the distance between their centers, that is C1, C2 will be equal to how much? From C1, if I take it to the circumference of the circle, it is going to be R1. From C2, if I draw a line segment like this, it is going to be R2. Now, what is C1, C2 equal to? Can I call it as R1 minus R2? Can I say this or not? Yes or no, guys?
Yes, sir.
So this is what they mentioned in the competition window. So now read the statement. When two circles touch each other internally, the distance between their centers is equal to the difference of their radii. So bigger radius minus smaller radius will give you the answer. Okay. Next. If anybody is noting down and you want me to wait, please let me know. Okay. If two circles if two circles touch each other externally, right? So if one circle is like this and the other circle is like this, if they both are touching each other externally and you have two centers C1 and C2, then the distance C1, C2 will be equal to how much? R1 plus R2, accepted? Right? So, having said this, let us look at the illustration number 1 that is given in the book. So, in illustration 1, they have told two circles touch each other externally. What is happening? Two circles touch each other externally. So, I'll just go with the diagram. One and a two. So when two circles touch each other externally, this the sum of their areas. So this is A1, this has area A1 and A2. So A1 plus A2 is equal to 149 is equal to 149 pi centimeters square. Be careful with the units, okay? And the distance between their centers C1, C2 is equal to 17 centimeter. Okay, but what is C1, C2 equal to? Is it not equal to R1 plus R2? So R1 plus R2 is 17 centimeter. Find the radii of the circles. How do we proceed? So pi R1 square plus pi R2 square is how much? It is 149 pi. Am I right? So pi and pi will get cancelled, which implies R1 square plus R2 square is going to be equal to 149. Any doubt till this step? Any doubt?
No, sir.
No, sir.
So our job is to find the value of R1 and R2. Now observe, R1 plus R2 is 17 centimeter and R1 square plus R2 square is 149. So I have to go to the other slide. I will write it, then I'll show you to copy. Okay. So R1 plus R2 is 17 and R1 square plus R2 square is going to be equal to 149. Now this R1 plus R2 the whole square, how can I write it as? Can I write it as R1 plus R2 the whole square minus 2R1 R2 is equal to 149. Can I do this? So R1 plus R2 the whole square will be 289 minus 2R1 R2 will be equal to 149, which implies 2R1 R2 taken to the other side, 149 to the left hand side. So 289 minus 149, how much is it going to be? It is going to be 140. Am I right? So 140 will be equal to 2R1 R2, which implies R1 into R2 is equal to 70. So let this be 3. Am I clear? Is it clear till this step?
Yes, sir.
Very good. Now see, since I have two variables, I need two linear equations to solve the problem. Right? So how do I get the other equation? Or what I can do is, from here, from this R1, R2 is equal to 70. From here, I will write R1 is equal to 70 divided by R2. Can I do this? Okay. Now I'll take this and substitute it here. So what I'll get is R1, sorry. So I'll get 70 divided by R2 plus R2 is equal to 17. So I'll get 70 plus R2 square minus 17 R2 is equal to 0, which implies R2 square minus 17 R2 plus 70 is 0. So it is a quadratic equation in R2. So I can factorize it like this: R2 square minus 10R2 minus 7R2 plus 70 is equal to 0. Can I do this?
Yes, sir.
Right. What will happen is R2 minus 10 into R2 minus 7 is equal to 0, which implies R2 is equal to 10 or 7. So the meaning of this is When R2 is going to be taken as 10, then R1 will be 7. If you take R2 as 7, then R1 will be 10. Because that is what this product tells me. So what they asked, they didn't ask the radius of the corresponding circles because we don't know which one is smaller and which one is bigger. They never mentioned anything about it. They asked only the radii of both the circles. So if radius of first circle is taken to be say 10 centimeter, then the radius of the second circle will automatically become 7 centimeter. So that 10 plus 7 is still going to give you the 17. Am I clear with this?
Yes, sir.
Yes, sir.
So make a note of it. Make a note. Shall I proceed? Okay. So look at the second problem that is given. So the cost of fencing a circular field at a rate of 24 per meter is 5280. So cost of fencing per meter is how much? 24.
24.
What is going to be the total cost? It is 5280 rupees. Right. The field is plowed at a rate of the rate of plowing is per meter square is 0.5. So what is going to be the cost of plowing the whole field? So how to solve this? So they are charging a rate per meter square, means the rate is charged per unit area. So can I say rate is charged per unit area? Is that right? Now how to proceed? So how to find? So here I need one parameter for me to calculate the total cost. What is it? I need the radius. Because radius is never given in the question. But why did they give the cost of fencing per meter? So fencing is generally done at which place? Is it done for the area or for the circumference?
The circumference.
Circumference. So they have told that the total cost for So if I take the radius of the circle as r, if radius is considered to be r, then 2 pi r multiplied with 24 should be equal to how much? 2 pi r multiplied with 24 should be equal to how much?
5280.
5280, which implies 2 pi r will be equal to 24. Does it cancel 5280? I think it is going through 20 times. Yeah. So it is 220 times, which implies 2 into pi is how much? 22 by 7 into r is going to be equal to 220. So this and this will get cancelled. So it will go 5 times. So the radius of this particular field is going to be 35 meter. Right. Now they want the total cost of plowing the whole area. So the total area is going to be equal to how much? Pi r square. So that is 22 by 7 into r square is 35 into 35. So this goes 5 times. Right. So 35 into 110. How much is the answer? 35 into 110 is going to give us 3850 meter square. Right. So cost per unit area is 0.5. So the cost for total area will be 0.5 multiplied with 3850. Are you guys able to understand the logic? So 0.5 into 3850. So half of this value, how much is it going to be? 1925. Right? It is going to cost 1925 rupees. Okay. So I hope you all copied it. So shall I proceed?
Yes, sir.
Then I'll see. Area of sector and segment of a circle. So this is the next topic. Area of a sector and segment of a circle. Okay. So if I take a circle, right? I'm just taking two circles. And for one of the circles, I'm drawing a chord like this. You know what is a chord? So what is a chord? Chord is basically a line segment, which is drawn internal to the circle. So chord is a line segment that is drawn internal to the circle. So let's name the chord as AB and let me take a point L here. Right. Then what is this portion called as?
Minus segment, sector,
So it's called
minus segment.
minor segment. So segment is a portion, right? So why do you call it as minor segment? Because if you take a circle, that circle can be broken into small chunks with the help of a chord. Is that right? Am I clear? So it can be
Yes,
broken
sir.
into a chord. So when you draw a chord, it always divides the circle into two parts. Right? So the part which has a bigger arc. The portion which contains the bigger arc along with the chord is called as the major segment. And the portion that contains the smaller part is called as the minor segment. I hope this point is clear.
Yes, sir.
Right. Similarly, from the center, okay, if I take this to be the center, let us say I am drawing two radii. What am I doing? I am drawing two radii. Obviously, both are going to be of the same value r, such that both these radii subtend an angle theta here. Right? Then you get a portion here. What is this portion called as?
Sector.
Minor sector.
Minor sector, and the sector which consists of the bigger arc is called as the major sector. Am I clear with this? Right?
Yes, sir.
Now our job is to find what is the area of a sector. So how to find it? So the formula is area of sector. How to find it? So I want the area of this shaded portion. So how do I find it? You have a formula, no? Theta something, theta by 360.
Theta by 360 degree into pi square.
How we-
Pi square.
What is the logic behind that particular formula? It's very simple. Okay.
The circle totally is 360 degrees, and in that theta is the part that we need. So we will just do area of the
You-
circle into three.
That's
Yeah,
right.
so
That's right. So if you take a circle, right, when you keep the compass and rotate the compass through 360 degrees. So when the compass is rotated through 360 degrees, what is the area it is able to cover? Will imply that the area generated by it will be pi r square. Right. Whereas if you take the compass and rotate it only through an angle theta, right? So when the angle is theta, what would be the corresponding area? So what I'm doing is, observe, 360 degrees is equivalent to an area of pi r square. Then theta will be equivalent to how much value? Right? So you'll just cross multiply. So if I take that area to be A, 360 into A will be equal to pi r square into theta. So what will be the value of area? Area will be equal to theta divided by 360 into pi r square. So I hope it is simple, right?
Yes, sir.
Make a note of this. Right. So based on the same logic, now we are going to find the area of segment. Okay. So what is it? So basically, if I have a sector, can I say sector is the sum of, can you fill it? Can someone fill the statement? Complete it. Sector is the sum of
Corresponding
Segment and
triangle at the segment.
sum of the triangle and the segment. So I'm not talking about major sector or minor sector. I'm just saying sector is a sum of the triangle that is formed by the radii and the chord. Right. So if I take this to be OAB, now our job is to find the area of the segment. So can I say area of sector is equal to area of triangle OAB and area of segment ALB. Can I say this? So what is the area of sector? Theta by 360 into pi r square. So if I take this angle to be theta, so it is theta by 360 into pi r square is equal to, what is the area of triangle OAB? Can someone tell me? As of now, you don't know this formula, but I'll keep it. So let's call it as area of triangle OAB only. Okay. So what I'll do is I'll push it to the left hand side. So theta by 360 into pi r square minus area of the triangle OAB is equal to area of segment ALB. Clear? Is it clear?
Yes, sir.
But I told you I need to explain you how to calculate the area of triangle AOB. Can some OAB? Can someone tell me what is the logic? So they have given some formula in the textbook, but I don't know how it has come actually. Now one logic is, if this is R, this is also R, what kind of a triangle does it form? Forms an isosceles triangle. Right.
if you draw a perpendicular from O, it should bisect AB.
It should bisect AB because perpendicular drawn from the center to the chord bisects the chord. Or you can say it is the same thing applicable to a triangle also, isosceles triangle. That's right. So if this total angle is theta, right, how much will this angle be?
Theta by 2.
So if this is theta by 2, this is also going to be theta by 2, then how much is this? Is it not 90 minus theta by 2? 90 minus theta by 2. It is not 90 minus theta the whole divided by 2. No. 90 minus theta by 2 because this OMA forms a right angle triangle. Is that clear? Am I clear with this?
Yes, sir.
Now my question is, how do I find this length? So if I take the triangle OMA, right, this is R, this is theta, then how do I find this side? Can someone tell me? What is AM divided by R? Oh, this is not theta, theta by 2, sorry. AM divided by R is? Basic trigonometry, huh?
Sine.
Sine of how much? Sine theta by 2. So AM is equal to R times sine theta by 2. Accepted? Accepted. So AM is R sine theta by 2 and MB is also R sine theta by 2. Right? What is OM? So I'm writing it here. What is OM divided by R equal to? It is cos theta by 2. Accepted? So OM divided by R is cos theta by 2. Accepted? So OM will be equal to R cos theta by 2. Accepted? Is there any doubt till here? Guys, is it clear or is there any confusion? I'm just taking the applications of trigonometry. Is there any confusion to anyone?
No, sir.
Good. So if AM is R sine theta by 2, MB is also R sine theta by 2, then what is AB going to be? Is it not 2 times R sine theta by 2? Accepted?
Yes, sir.
Now listen to this step. Now what is going to be the area of triangle OAB? Half into base, that is AB, into height, that is OM. So half into base is how much? 2R sine theta by 2 into OM is how much? R cos theta by 2. 2 and 2 will get cancelled. So what I left out with? R square sine theta by 2 and cos theta by 2. Is there something like that you are able to see in page 340? In page 314, the fourth step from the bottom of the page. Did you understand? So theta by 360 into pi r square minus r square sine theta by 2 into cos theta by 2. Right? So this is going to be the area of this segment. Okay. So something new you have learned today, please make a note of it. Shall I proceed? Yes or no? Shall I proceed?
Yes, sir.
Now see. So let us look at the illustration number 3. So what is it saying? A sector is cut from a circle of radius 21 centimeter. The angle of the sector is 150 degrees. Find the length of the arc and the area. So there is a sector which is cut from the circle. So that the angle of the sector is 150 degrees. The radius is 21 centimeter. Here also you have 21 centimeter. Find the length of its arc and area. So if I take this as AB. 1 minute. So if I take the length as AB, I need to find the length AB. How do I find it? So what is the length of this arc, by the way? It is theta divided by 360 into 2 pi r. How did we get? Same logic. So 360 degrees is equivalent to 2 pi r. Then theta degrees will be equal to how much? It will be theta by 360 into 2 pi r. So just substitute that. How much is the value of theta? 150. 150 by 360 into 2 into pi is 22 by 7 into r is 21. So it is going to be 3 times. Cancel these two. So it is going to be 18. There's 5 times, 6 times, 2 and 11. Answer will be 55 centimeters. Right? It is going to be 55 centimeters. Then what is going to be the area of the sector? Area will be theta by 360 into pi r square. So theta is how much? 150 by 360 into pi is 22 by 7 into r square. That is 21 into 21. We get cancelled. Thrice. So gone. This is going to go 5 times. This is going to go 12 times. 11, 6, 2. So it is 55 into 21, the whole divided by 2. Okay. Multiply and calculate the answer, and it should come out as 577.5 centimeters square. Is it clear? Right. Shall I proceed? So look at the fourth illustration. The minute hand of a clock is 10 centimeter long. So there is a clock whose minute hand is 10 centimeter long. Find the area of the face. Find the area of the face of the clock described by the minute hand between 9 a.m. to 9:35 a.m. So how to solve this? For that, you look at the competition window. So when you look at the competition window, they have clearly mentioned it. Angle described, right? Angle described by the hour hand in 12 hours is how much? 360 degrees. Means a hour hand is going to take one complete revolution. It takes 12 hours to complete 360 degrees. Right? So the same angle described by the hour hand in 1 hour is going to be how much? It will be 360 divided by 12, which is going to be 30 degrees. Similarly, if I talk about the angle described by hour hand in 1 minute, then how much will it be? It will be 30 divided by 60. Right? So that is going to be half a degree. So you conclude that hour hand rotates through half a degree in 1 minute. Now, having this knowledge, tell me what would be the answer for the fourth one. Oh, this they're given with respect to R and no. What about the minute hand? Sorry. Here they have given about the R hand, but they asked the question they have asked about the minute hand. Am I audible?
Yes, I am.
Yeah.
Sir.
So read the question carefully. So what are they asking? The minute hand of a clock is 10 centimeter long. Find the area of the phase of the clock described by the minute hand when it moves from 9 a.m. So minute hand, it was at 9 a.m. like this, and 9:35 a.m. it will be like this. So what is the angle covered by it? See, what is the angle covered by the minute hand in 5 minutes? Or what is the angle covered by it in 1 minute? See, I'm asking you a question. What is the angle described by minute hand in 1 minute, guys? How much is it? In 1 minute, how much revolution does it take place? It is 360 by 60. See, minute hand completes 360 degrees. So 360 degrees is covered in how many minutes? In 60 minutes. Am I right? In 1 minute, how much will be the rotation it does? 1 by 60 into 360, that is going to give you 6 degrees. So it is going to cover 6 degrees. Now, how many minutes has it covered between 9 to 9:35? Which implies in 35 minutes, how much angle will it cover? Angle swept by the minute hand will be how much? 35 into 6, which is going to give you 210 degrees. So when there is 210 degrees being swept, can you calculate the area of the sector? So area of the sector will be equal to theta by 360 into pi r square. So theta is 210 divided by 360 into pi is 22 by 7 into r square. R is how much? 10. So 10 into 10. You get cancelled, it goes 7 times, it goes 12 times. 11, 6, 7 and 7 are gone. So I can write this as 3 and 50. So 500 into 11. So it is going to be 500 divided by 3. So how much ever you are going to get, that will be the answer. So answer is 183.3 centimeters square. Is it clear? Yes, sir. Hello. Is it clear or not?
Yes, sir.
Good. So let us look at the fifth problem. Find the area of the segment AYB shown in the figure. The radius of the circle is 21 centimeter and angle AOB is 120. So there is a circle like this. A, B, and here it is Y. Here it is going to be 120. This is 21. This is 21. Is it clear? So they're asking the area of the segment. So how to solve this? Just now we saw the formula. What is the area of segment? That is area of sector minus area of triangle. What is the area of sector? Theta by 360 into pi r square, which implies theta is how much? 120 by 360 into pi is 22 by 7 into r square is 21 into 21. It goes 3 times. 3, 3 and 3. So it is 22 into 21. So 22 into 21 is going to give you 462 centimeters square. Now, how to find the area of triangle? Area of triangle, we already saw the formula. It is r square sin theta by 2 cos theta by 2, which implies 21 into 21 into sin 60 into sin 60. That implies 21 into 21 into root 3 by 2 into root 3 by 2. So what is going to be the answer? 462 minus 21 into 21 is going to be 441. Divided by 2 into 2 is going to be 4. And here it will be 3. I think there is a mistake in the problem. Oh, sorry, it is my mistake. R cos theta by 2, no? So it is cos 60. So cos 60 is going to be half. So cos 60 is going to be half. So it will be 441 root 3 by 4 centimeters square. So this will be the answer. Okay. Shall I proceed?
Yes, sir.
Okay, good. So go to page 316. In page 316, if you see, you have areas of combinations of plane figure. Areas of combinations of plane figures. Right. So based on that, we are given a problem like this. In the given figure, A, B, D, C, A. A, B, D, C, A. Okay. So you have something like this. A, B, D, C, A. Right. Represents the quadrant of a circle of radius 7 centimeter. So this is 7 centimeter. This is also 7 centimeter. With the center at A. Calculate the area of the shaded portion. So there is a point E here. From E, I'm joining it to B so that E is at a distance of 2 centimeter from the center. Right. How to calculate this area? What is the logic? Area of shaded region is equal to what?
Area of sector triangle.
Correct. Area of sector minus area of triangle EAB. So what is the area of sector? It is 1/4 of pi r square. Why? Because it is quarter
Quadrant.
circle. It is 1/4 of a circle minus what is the area of the triangle? Half into base into height. Base is 7, height is 2. So 1/4 into 22/7 into r square. What is r square? 7 into 7. So 7 and 7 will get cancelled. This is 11. This is 2 minus 14/2. So it is going to be 77/2 minus 14 divided by 2. How much is it? 63 or 63 divided by 2 centimeters square. That is 31.5 centimeters. Right. Okay. Next one. The seventh one is the given figure shows the sector of a circle with center O containing an angle theta. Prove that the area of the shaded region is r square by 2 into tan theta minus pi into theta by 180. We'll do that. So you have a circle. Okay. O goes to A. B. Join at like this, then this angle is going to be theta. So you need the area of the shaded region. How to do it? What is the area of shaded region here? Area of something minus area of something. Fill in the blanks. Area of triangle OAB. So you have a triangle. From the triangle, what are you supposed to remove?
The sector.
So the portion you are supposed to remove, I am marking it with yellow. I'm sorry that the marker took the top one also. I hope you're able to understand. Minus area of sector. So what is the area of triangle AOB? That is half into base. What is the base? Half into base into height. Height is
AB.
AB. Minus what is the area of sector? Theta by 360 into pi r square. Right? So half into what is the value of OA? OA is the radius, no doubt in that. But what is AB? What is AB? So if you observe, AB divided by R is equal to tan theta. So what will AB be equal to? R tan theta. So substitute it here, R tan theta minus theta by 360 into pi r square. So if I take out r square out, then I'll get tan theta by 2 minus theta by 360 into pi r square. So if I take this 2 also outside, I'll get r square by 2 into tan theta minus theta divided by 180 into pi r square. So this is what they asked us. Oh, sorry, 1 minute. So here it will be pi. Here it will only be pi. So I don't know why it is coming, but this is not there. This r square is not there. And sorry, pi r square itself is not there. I hope this point is clear. Right. The next point is so one last problem. In the given figure, there are two sectors of two concentric circles of radii, 7 centimeter and 3.5 centimeter. Find the area of the shaded region. So this is going to be 30 degrees. This is ODB. This 3.5 centimeter. OA is 7 centimeter, and this point is like this. And this is going to be the shaded region. So how to find the area of shaded region? Area of big sector minus area of the small sector. So how much is it going to be? 30. So if you observe one thing, theta by 360 into pi r1 square minus theta by 360 into pi r2 square. But what is the value of theta in both the cases? It is going to be 30 only. So I can take that theta by 360 into pi outside. I'll have r1 square minus r2 square. So theta is 30 divided by 360 into pi. Pi is actually 22 by 7 into r1 square. R1 square is 49 minus r2 square is 49 by 4. So how I wrote directly is because 3.5 is actually 7 by 2. So 7 by 2, the whole square is 49 by 4. So it goes 12 times, 11 and 6. So 11 by 6 into 3 by 4 times 49. So it goes 2 times. So 49 into 11 divided by 3.
11 by 42, sir.
42. Did I make any mistake? Is there anything wrong?
No, sir.
I left the 7, sir.
Where did I leave 7? Oh, in the denominator. Okay, okay. Then it is going to be 7. So answer is 77 by 8. I think that's what is given. Yeah, 77 by 8 centimeters square. Now it is fine, no? Yeah. Okay. So that's all for today. Next class we'll solve some level 1 problems. So after this chapter, what is taught in your school? So areas related to circles is over there.
Circles.
Circle. We'll do that. Okay. So tomorrow for first half we'll do some problems from the level 1. And then
LDG.
we'll go to circles. Okay. Any other doubt?
No, sir.
Okay, then we'll wind up. Let's see what.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.